The Sussex coast is subjected to strong southwest incoming wind, as well as large tide variation and strong current. Coastal engineering has therefore been used extensively in a wide range of solutions in order to prevent cliff erosion and littoral drift. The Brighton Marina construction started in 1971 and was an ambitious project, as it was the largest European marina at the time of its construction. Tube berthed water protects the berthing area, where you can see that the berths have been laid out to face the direction of the wind. The tube breakwater were built out of tubular caissons. Caisson construction was an innovative technique that consists of sinking large hollow tubes of concrete that are then sealed to the ground using concrete, sand, and water. Next to the inner breakwater, we can see that wave-absorbing duluths has been used in order to capture the wave in. This protects the breakwater against scouring, for example, and ensures that no increase in wave height occurs due to the reflected wave. However, the Brighton Marina provides locals with more than berthing for yachts, as the engineer focused on bringing a societal activity around the marina. As a matter of fact, a supermarket, a casino, and housings with private berthing spots can be found on the north side of the marina. To the west of the marina is located the undercliff wall, where concrete construction has been used to prevent cliff erosion through the action of waves. It should also be noted that grounds have been used all along this portion of the coastline in order to hinder the littoral drift. Further down to the west lies New Haven, where two breakwaters have been built to protect the entrance to the river against corrosion, but also to act as grounds in order to use the littoral drift in a favorable manner. As a matter of fact, if the inner beach has been artificially created through replenishment, the western beach was naturally created over time under the action of littoral drift. The eastern breakwater has been built in the hope of having a positive impact on the eastern beach by using the current inversion due to tides. As we continue to move along the coastline, we reach a point of particular interest when it comes to cliff erosion. Burling Gap has been subjected to dramatic cliff erosion, with erosion rates reaching as high as 3 meters in the year. Here, civil engineers decided to let nature evolve, and no work has been done to slow down the erosion. The two houses in the picture are the remaining of a group of 4 that had to be deconstructed due to their ever-growing proximity to the edge of the cliff. A few hundred meters to the west, another building was endangered by cliff erosion. The Belted Lighthouse, located on top of the cliff, was close to collapse when engineers decided that it should be lifted and moved back 17 meters in order to ensure its safety. Arriving in Eastbourne, we notice that grounds have been built all along the beach, delimiting the beach in parcels in order to hinder the littoral drift. The old wooden grounds have now reached their design lifetime and are in the process of being replaced by larger timber grounds with a rubble mound cover. Further down to the west, we arrive in Penvenson Bay, which represents a particular point of interest in terms of coastal engineering. As a matter of fact, if the ancient undertaken here are classic and similar to the one previously seen, use of grounds and beach replenishment, they are part of a worldwide unique contract. A public-private partnership exists over a period of 25 years and gives a contractor a responsibility in terms of. Finally, we reach Hastings, where again grounds as well as beach replenishment has been extensively used in order to slow down the littoral drift.